Welcome back to our trek through the depths of the Godot 4 documentation. The link to this lesson can be found in the description. If you enjoy software and game development educational content like this, kindly support the channel by liking and subscribing to keep the bookworms at bay. Thank you so much. In this video, we are going to be looking at using signals. Any node in Godot can or does emit signals when some specific things happen to it, like when a button is being pressed. Other nodes can connect to individual signals and react to selected events that follow. You can use signals for a lot of reasons. Some reasons include entering and exiting a world, or some, for example, or the size of the interface, a coin collected, or so on and so forth. In programming, there is a concept called coupling. A high level of what this means is that when you have a code that references other code in other scripts, your scripts become dependent on each other. They have become tightly coupled and can lead to what is sometimes called dependency hell. It is a nightmare to debug sometimes if this happens. Signals help us by removing the need for our scripts to need to know anything about who is listening to them. Or put more verbosely, they are a delegation mechanism built into Godot that allows one game object to react to a change in another without them referencing one another. This is the Godot version of the observer pattern. The documentation links to an article that explains what that is, so I will link it in the description as well. Again, we will have a dedicated course on programming in the future. Now let's get started with some programming so that we can get a sense of how this works. Making sure that we have the project opened from the last video, let's create a new scene by clicking the plus button here and name it whatever you'd like. Leaving it as Node 2D is also fine. In this scene, make sure that you click on 2D Scene and add a Node 2D as our root. This is because we are making a 2D game here and want everything that follows it to be 2D as well. Now let's drag in the scene that we made previously. Grab the sprite 2D from the file system doc down here and just plop it right onto the Node 2D root node. This will automatically child it. Now we want a sibling node to the scene we made, so click on the root node itself. Then click the plus icon to create a child node of it. Search for a button and add it. It's probably pretty hard to see it, so make sure that you have the select tool active in the toolbar, and let's grab the handles and make it a little bit bigger so that we have something to work with. Now let's move the button a little closer to our icon so that you don't have to move the mouse as far. If you look in the inspector, you can change this text field to be anything that you want. This will add a label to your button. However, it might be best to actually have the button say what it's supposed to do, unless you are the type that's feeling a bit risky and like clicking the unlabeled red buttons when you shouldn't. Let's just say it toggles motion. If we run our scene as it is, nothing will actually happen here when we click the button. We haven't wired anything up yet, so we don't have anyone listening for our on-pressed signal yet. We are going to make it so that our sprite cannot move if the movement is toggled, so we will need to handle that in the sprite 2D script that we have already made. We want to connect the pressed signal that the button emits to that. But how do we do that? Glad you asked. You can do it with the node doc. Right here beside the inspector, you will find it. The doc displays a list of signals available on the selected node. If we double-click on the pressed signal, Godot will open a window and save us some trouble of having to type a function manually. From here, if we click the sprite 2D node, it will open the script attached to it and automatically add what's called a receiver method. Aptly named when a signal is emitted, like when the button is pressed, this method will receive that signal and then execute the code that we defined in the body of that method. But something to note, we can toggle this advanced toggle. We see two views here. When connecting signals via the editor's node doc, you can use two modes. The simple one only allows you to connect to nodes that have a script attached to them and creates a new callback function on them. The advanced view lets you connect to any node and any built-in function, add arguments to the callback, and set options. You can toggle the mode in the window's bottom right by clicking the advanced button. But as long as we have the sprite 2D selected, let's click the connect button to complete the signal connection. The script workspace for the sprite should open up here. We can see the method _on button pressed has been added. Receiver methods usually follow this naming convention, but you could have named it anything before clicking connect. If you click the icon to the left of the method, a window pops up and displays information about the connection. This feature is only available when connecting nodes in the editor. Now let's put something in here so that it does something. If we replace the pass with set process, it will be kind of, in a sense, like we are turning this node off and on. We will enable or disable the process method with this. Each node has a method called isProcessing. This will always return a Boolean value, so let's use it as an argument for set processing. But we want it to always return its opposite, so we have to put not in front of this argument. Remember, it's implied that there is a self dot in front of this method, so it's kind of like it's turning itself off and on when this signal is received. Let's run our scene. You will find that now if we press the button, we can no longer move, and if we press it again, we can. But if you want to make this more interesting, you could use the code from an earlier video that will make it so that your guy moves on his own. You have to use the button to control whether or not he moves. Awesome. So now we know how to add signals the easy way. But what about if we want to do it with code? Let's say we are building a roguelike or something, and we need things to happen programmatically. Or really, anytime you are instantiating a node, you will need to wire it up somehow without being able to use the interface. This time, let's add a timer node, but as a child of the Sprite 2D node. We are going to make our icon blink on a timer. If you press Ctrl F1, you can quickly switch back to the 2D workspace. Click on the Sprite 2D and click the plus icon to add a child node. Then search for the timer node and add it. With the timer node selected, go to the inspector and enable the Auto Start OS property. That means that it will start as soon as it is in the scene. We will talk about how the timer node works in a dedicated video. Next, click the script icon next to Sprite 2D to jump back to the scripting workspace with the script we want open. Now that we have done this, we need to do two things. 1. Get a reference to the timer node. 2. Call the connect method on the timer's timeout signal. Connect is a method that all nodes have. It lets you connect a receiver method to a signal from code. We use it to listen to other nodes. We want to connect the signal as soon as the scene is instantiated, so let's do it on _ready. In the ready method, let's define a variable called timer and set it to get node and pass in the name of the node that we want to get. In this case, it is called timer. This method just grabs a node from the scene doc and looks through the children of the node that this script is attached to for the name of the node that you specified. If you had named the timer anything else, the argument that you would pass in would be different. Next, we have to connect the timer's signal up so that this node will listen for it. Below the timer variable, let's call the timer and its timeout signal, which is the signal, and .connect. We want to specify what receiver method we are connecting by passing in _ on timer timeout. Again, we can name this method anything that we want. Calling it on doing something is just convention. It helps us to understand that this is a receiver method. We haven't defined this method yet, so we will need to do so to get rid of the errors that we see. Somewhere in your script, define func _ on timer timeout. You can do this anywhere, but for readability's sake, it's probably better to put it down somewhere below the process method so that it's a little cleaner. Most of your stuff that's going to be happening in the script will be happening in the process method, so I like to define it after that. At least, that is my opinion. Some might like to have all of their methods defined before the ready and process methods. It's a personal preference, I think. In this method, let's grab the visible property of the Sprite 2D that we inherit and set it to its opposite. Typing visible equals not visible will do just that. Now let's run the game. You will see now, after 1 second, the visibility of the sprite will toggle on and off. This is all fine and dandy, but it actually gets better. We can actually create our own signals and listen to them too if we need to. Let's say we have health. Shouldn't something happen when our player dies? On the Node 2D node, let's create a new script. Below the extends line, let's define a whole new signal. Type the keyword signal to specify that we are creating a new signal. And let's name it health depleted. Save the script. Now if we go back to the node doc, we see that we have a new signal here on the Node 2D node that we didn't have before. But even if we hook it up, it won't do anything. We haven't done any work to emit it yet. Going back to the script, let's define a variable for health. Let's do that. var health equals 10. Now let's quickly write a function that depletes the health. We will say func take damage and we will give it an argument called amount. In the method, we want to take the health variable that we defined earlier and subtract it by the amount that we passed into the function. And then we want to say that if the health is less than or equal to 0, the player has died. Therefore, we should emit the signal. You can do that by calling the signal and then typing .emit with open and close parenthesis. I will it as an exercise for you to implement this take damage function and hook the signal up. Perhaps you want the health to deplete when the spacebar is pressed? Give that a try. You should have the tools to do that now. Also, before we go, you could have actually defined the signal with arguments. There are many reasons why you might want to do this, but here is another way to deplete the player's health. Going back to signal, let's give it 2 arguments, one for old health and one for new health. And now in the take damage method, instead of just emitting the signal, let's pass a value for the old health, which we haven't actually defined, so you would have to figure that out for yourself, and then pass in the new health, which we just calculated. Now you should have a pretty good understanding of how signals work in Godot, and that will do it for this video. If you enjoyed this content, please like the video and subscribe to the channel. And thanks for making it all the way through the video. Please join us in the next one. See you next time.